Hello. This presentation was prepared as part of the AHI 671 course on healthcare databases taught by Dr. Abdul Hassef at George Mason University. I am currently a graduate student in the Health Informatics program at George Mason and will be studying project management. Here is my presentation on my class, which is a Teach 1 on Module 4 Database Design. Here are the topics in which I'll cover for the presentation. These include database process design, data model, keys and attributes, relationships, some best practices, and a conclusion highlighting some key takeaways. First, starting off with the database design. This follows several structured steps in which we first determine what information the database needs to store and who will use it. Then we create a conceptual design using an entity relationship or ER diagram. Next, we'll organize the database structure, remove redundancies, optimize storage and performance, and finally, design the application interface and security controls. With the first step, part of it is understanding the problem first before we build anything. We want to identify what data needs to be stored, who will access it, and how it will be used. For example, a hospital database may need to support doctors, nurses, and administrative staff. The conceptual design in step 2 creates a blueprint of the database. We use the ER model, which I'll go over, to identify the main objects, their characteristics, and how they relate to one another before getting into the technical details. Next, a logical database and design, we carefully evaluate for information and we prep the data which will be ready for the real world use. Step 4 through 6, in a schema refinement, we focus on improving database structure. We eliminate any redundancy and we normalize the data. On step 5, this is the physical database design. This is the most efficient way in which we want to retrieve the data and determine how we want to store it. And last, application and security design. This is more on addressing the user interface and access controls to secure access to the data. Now going into the ER data model. An entity is and represents any real-world objects. It can be living or non-living that can be clearly identified and about which data can be stored. It may be a physical thing, or it can be an enterprise or an event that happens in the real world. Examples of entities can include people, places, objects, events, or concepts. So for example, a person can be an employee, a patient, a customer. A place could be a physical place like a building, a warehouse. An object could be a car or a book. An event could be a renewal, a transaction, and a concept could be an account, course, department, and project. There is also a piece of this in this data model called an entity set. An entity set is a group of similar entities that share common attributes. For example, all patients in a hospital form a patient identity set. And identities are represented in the ER diagram with a rectangular box with the entity name written inside. Entities are represented by their properties, which are also called attributes. As you can see, attributes underneath the entity section, they all have their separate values. A good example of this is a patient entity may have a name or an age as an attribute. Next, in the ER data model, we have something called relationships. A relationship represents an association between two or more entities, and relationships are typically identified using verbs or verb phrases that describe how the entity interacts with each other. So in an ER diagram, relationships are represented using a diamond shape in which in the data model is represented. For example, Mary works in the nursing department. This is a good way to show the relation of a department in which Mary works and describes it as a verb. So in a way, we want to think it as three building blocks. Component is an entity. We want to think of it as a noun. An example could be a patient. The component attribute, we want to think of it as a description. An example of this could be the patient ID or the name. And the component for relationship, we think of it more as a verb. This person, patient, will visit the clinician. Now that we understand what an entity is, the next step is describing the information that belongs to the entity. In an ER model, we use attributes to describe the characteristics or details of an entity. For example, a patient entity may have attributes such as patient ID, first name, last name, date of birth, or gender. These attributes represent the information we want to store about each patient. Each attribute also has a domain. This defines the possible values that an attribute can contain. For example, a patient ID may have a domain of numbers, while a date of birth must follow a date format. A gender field may use a limited set of values such as male, female, or unknown. And last, a primary key is a special attribute or combination of attributes that uniquely identifies each record and entity. For example, a patient ID is used as a primary key because each patient has a unique identifier. Even if the two patients have the same name or birth date, their patient IDs will be different, as you can see an example on the right-hand side. Primary keys are also important because they help prevent duplicate records. This allows us to connect related entities together, such as linking a patient to their visits or medical history. Now, you might have heard me mention before about relationships. And once again, we want to call and think of relationships as a verb because they connect entities together. But relationships can have attributes too. For example, the visit date. The best example to give is a patient goes to a visit and goes to the clinician. As part of this relationship, there's something called cardinality, which describes how many instances of one entity can be associated with instances of another entity. In healthcare database, this helps us define how patients and clinicians interact. For example, a patient has medical record numbers. Part of this relationship types, there are also several examples in which are given, and on the right-hand side, you can see some of these relationships. The first one I want to talk about is one-to-one, which basically means one entity is one group and associated with only one entity from another group, and the relationship works both ways. So an example is each patient has one unique medical record number, and each medical record number belongs to only one patient. This type of relationship is less common because many systems combine these details into a single entity. The next one is one-to-many. An example of this is a clinician goes to treat a patient. One-to-many means that one entity can be associated with multiple entities, but each entity on the other side is associated with only one. An example of this is one clinician can treat many patients, but each patient is assigned to one primary clinician. This is one of the most common relationships in healthcare databases. The next is many-to-one. An example of this is a patient is assigned to a clinician. Many-to-one is the reverse way of looking at the same relationship, but many patients can be assigned to one clinician. Each patient is linked to a single clinician. Their direction changes depending on which entity where we are starting from, but the relationship is the same. And the last is many-to-many. For example, patient visits clinicians. Many-to-many means that multiple entities on both sides can be associated with multiple entities on the other side. For example, one patient can have many visits and one clinician can see many patients. In a relational database, many-to-many relationships usually require a separate entity, such as visit table to store the details of interaction like visit date, diagnosis, or treatment. Once we've identified our entities, attributes, and relationships, we refine the design to make it efficient and easy to maintain. Here are some best practices that I've learned and were mentioned in our module. First, we eliminate redundancy, which means we avoid storing the same information more than once. For example, a patient's diagnosis should be stored in a visit entity instead of being repeated in the patient entity. We use clear and consistent names for entities and attributes so everyone understands the data. We also validate the design against the requirements to ensure the database supports everything users need. We keep diagrams readable. It's often better to create multiple simple ER diagrams instead of making one large cluttered diagram. And we also document assumptions, review the design with stakeholders such as business users, developers, to confirm the database accurately represents the real world process. In conclusion, database design is a structured process that transforms business requirements into an organized and efficient database. The entity relationship ER model serves as the foundation of this process by identifying entities, attributes, keys, and relationships before we implement. By following good design practices such as eliminating redundancy, using clear naming conventions, and validating the design against user requirements, we create databases that are accurate, scalable, and easier to maintain. Ultimately, a well-designed ER model helps ensure data is stored efficiently, supports the business needs, and provides a strong foundation for building reliable database systems. This concludes my Teach 1 for my course at George Mason University. Thank you so much for listening, and I hope that you found this helpful.